Today I'm going to talk about a paper that we just got accepted to EMLP 2020 as a short paper. The title is An Information Theoretic View on Selecting Linguistic Probes. We wrote this paper in sort of an argumentation style, trying to contribute to a recent debate by two papers. Harry Liang 2019, Best Paper Award winner at EMLP 2019, and Pimento et al. 2020. The task is about finding linguistic information from neural network representations, or diagnostic probes, or diagnostic classifiers. Let's trace that all the way back to the 2019 Allen and Benjo paper to review about what this diagnostic classifier setting is about. Because neural network representations are black box, it is hard to know which types of information does each layer of representation is encoded. So they proposed to use a diagnostic classifier that takes in an input R from the neural translation system, and they try to probe some target T. 2 years later, Harvey and Manning in 2019 showed that this diagnostic classifier task setting could be used to probe syntax tree distance from the sentence and word representations. A few months later, they showed that the good probing result, which is traditionally considered as a low classification loss, could result from either of the following two reasons. First, the representation is rich in the information you want to probe. And second, the probe learns the task. Without giving an information theoretic formulation, they proceeded with using experiments to verify this dichotomy. They recommended that we should use the probes that are as simple as possible to avoid the probe learning the task, because this limits the capacities of the model, of the probing model, so that whenever we see the low classification loss, we know it's more likely that the representation is rich in those information. In addition, Harvey and Liang 2019 proposed to contrast the probing loss with a probing accuracy with the accuracy of a control task. The control task is basically a same probing task setting, but they randomize the target. Later, Pimento et al. In ACL 2020 proposed that argued that this dichotomy is incorrect, and they argued in their information theoretic formulation. Contrast to Harvey and Liang's control mechanism, they proposed another controlling mechanism, which is the control function. In control function, Pimento et al. Randomized the input representations towards the probes. So they randomized R. They computed the errors of what is measured from the probing task and what is actually they want to measure. And they showed that the error is of their measurement, the error of their controlling mechanism, it can be represented by the difference of a pair of KL divergence. We'll cover that later. In this paper, we follow the Pimento's information theoretic formulation, but we show that the Harvey-Liang dichotomy is correct information theoretically. So let's dive into this paper. First, we want to give a formulation of this dichotomy. The purpose of the probe is to approximate the mutual information between the target and the representation. Note that this mutual information term can be written in the right-hand side, while the left-hand side is the cross-entropy loss that the probe is measuring. From this equation, we can see that the cross-entropy loss is equal to a constant term minus the mutual information plus a KO term. If we observe a low cross-entropy loss, it is likely that we either have a high mutual information of the code and target, or we have a low KL divergence between P and Q. Here, P and Q stands for P and Q of the target given the representations. P is the unknown true distribution, while Q is the posterior classification probability that the probe wants to approximate. This equation shows that this dichotomy is information theoretically valid, and this dichotomy is non-exclusive OR. Later, we discuss the criteria for a good probe. To get a good probe, we show that the criteria proposed by Liang and Pimento are equivalent if you are doing the randomization correctly. This goes along the intuition because no matter which one of the representation or the target is randomized, you are setting up a control experiment that does not give information. And if you take the difference between the performance of the original probing task with this control task, you get the performance gain from this useful setting. We actually did experiments in part of speech tagging using the universal dependency dataset in English, French, and Spanish. We found that the correlations between these two criteria are so high to the extent that they are comparable to the correlations of the accuracy and the cross-entropy loss. If you think about that, this is surprising because we usually consider the accuracy and cross-entropy loss of a classifier to be tantamount. They are basically the same thing if you want to select the models. So the correlations between these two control mechanisms are as high as the correlation between the accuracy and cross-entropy loss. This means that these two controlling mechanisms are basically equivalent if you are doing the randomization correctly. These are the outline of our paper. If you want to know about the details, I posted a link to our preprint on arXiv. Thanks for listening.